Hello everybody, this is the second part of the notes for section 1.6, the examples. Okay, the first video is just, here's the details, here's the terms. So, looking at this, I would like you to try these on your own, so hit pause and see how, give them a go, see how it goes. Alright, so, in the first set of questions, it says, tell whether the figure is a polygon. Alright, so looking at number one, it's got curves to it. Polygons are made of segments. It's not a polygon. The second one, those are all segments, so it is a polygon. But the other part of the question is it convex or concave? My definition for concave is if you can connect two vertices with a segment and that segment is outside of the polygon, it's concave. So, number two, it is a polygon and it is a concave polygon. Number three, those are all segments, so it's a polygon. They're all connected end point to end point. It's a closed plane figure. All the proper definitions are there. And if we try to connect any two segments or any two vertices with a segment, those segments are all going to be inside of the shape. So this is convex polygon. All right. Looking at the next set of examples, it says classify the polygon by the number of sides. So I'm just going to start at one side. There's 1, 2, 3, 4, 5 sides, so that is a pentagon. Now, also wants to know, is it an equilateral, equiangular, or is it regular? Remember, if it's going to be a regular polygon, all the sides and all the angles have to be equal. So looking at number 4, they're all the sides are 3 meters long, so it's equilateral. All these little arc things here at the vertices, those are saying all those angles are equal, so it's equiangular. It's both equilateral and equiangular. This here is a regular pentagon. Okay, looking at number 5, it's 4 sides, so it's a quadrilateral, and this one's actually called a rhombus, but we'll talk about that later on. But it's a quadrilateral, 4 sides. All 4 sides are congruent, so it is equilateral, but these two angles in blue are congruent, and these two angles here in red are also congruent, but they're different than the blue angles. So it is not equiangular, and it's not going to be regular. This is just equilateral, and it's a quadrilateral. Looking at number 6, it's a triangle, obviously, but all 3 sides are not the same, all 3 angles are not the same, and so it is just a triangle. That's it. Looking at number 7, these 2 sides are different than the other 4 sides. So it's not equilateral. These 2 angles are different than the other 4 angles. So it's not equiangular. But it does have 6 sides, so this is a hexagon. All right, so next example here. Says these 2 expressions represent the lengths in feet of 2 sides of a regular pentagon. Find the length of a side in the pentagon. It is a regular pentagon. All the sides are the same. That's a side and that is a side. They are the same. So there's our setup. 6x plus 36.5 equals 13x minus 54.5. Okay. So, to solve for x, I'm going to subtract 6x from both sides. I'm going to add 54.5 to both sides. I'm going to divide by 7. X is 13. Okay, I don't care what x is. The question is, find the length of a side. So, I'm going to plug this x value back into one of these expressions. And it doesn't matter which one because they're equal. So, 6 times 13 plus 36.5. All right, 6 times 13 is 60, 78 plus 36.5. So that's 108, 114.5. This said this was in feet. So this is a very large pentagon because that's the length of one side, and there's 5 of them. But that problem's done. All right, this last example says the figure is a regular octagon. Again, key phrasing. Regular. All the sides are the same. All the angles are the same. Question is, what's the values of x and y? So, looking at the given information, The four sides that we know information about, all the sides are equal, but we only know these four sides. They're all equal to each other. But what's unfortunate here is we don't have two of these with the exact same variables in it. Okay, we got x's and y's, but not just a single x or just y's. So we're going to have to do a system of equations. Now, we have lots of options. There's lots of ways you can set it up. But basically, because we are dealing with two variables, you have to have two different equations. So you just need to set two of these sides equal for one equation, two different sides equal for the other equation. I'm going to go x plus y equals 5x minus 4y for one equation. My other equation, I'm going to go with x plus y equal to 2x minus 4. All right? So here's my system. I got these two equations. Now normally they're written all together like this, but we got to do some work with each one. So that's why I'm kind of moving them apart. What I'm going to do is take this red equation and I'm going to solve for one of the variables. So I'm going to subtract x from both sides. So y equals x minus 4. I'm going to take this expression, that x minus 4, that's what equals y. I'm going to plug it into the other equation. Just doing the substitution method of solving systems of equations. So by doing that substitution, it gives us this. X plus, taking the y out, replacing it with x minus 4, to equal 5x minus 4. Again, I'm taking the y out, replacing it with x minus 4. So what we're looking at in this green equation here, it's one equation, and we just have the one variable of x. So now we can solve for it. So on the left side of the equal sign, I got a 2x minus 4 equal to, on the right side, got some distributive property. I'm going to take care of that first. 5x minus, distributing this negative 4. So it becomes a minus 4x plus 16. All right, so still have some like terms here. 5x minus 4x is 1x plus 16. We got 2x minus 4. Subtract x from both sides. Add 4 to both sides. X is 20. But we also need to solve for y. Well, there's our equation that says y equals. So y is x, which is 20, minus 4. There's our values for x and for y. And that's it. That's these examples, dealing with polygons, equilateral, equiangular, regular. Those are all clues to tell you and to help you get these relationships so that you can set up these equations and solve for the unknown variable or variables. All right, have a good night.